This is Mr. Wright. We're going to look at the segment addition postulate. So the segment addition postulate says that if I have points on a line, if two segments share the same point, then I can add those two segments together and it would create the entire segment. So for example, if I had segment AB would be 3. If BC equals 5, because AB and BC have a common point, point B in the middle, then I could add those two together and it would give me 8. That's how the segment addition postulate works. So a couple of key points. So this would be an example. If I have points x, y, and z are collinear, collinear has the word linear in it, so that pretty much means line. Co just means that they're going to be on the same line. So collinear on the same line. So what I'm going to do, so in geometry, you always want to draw a picture whenever they give you some information. So if they talk about like a line, a segment, if they say a triangle, an angle, whatever they're telling you about, you always want to draw a picture for it. So I'm going to draw these 3 letters on the same line. And then I'm going to add based on whatever they tell me. So they're telling me that xy is 14 and yz is 8. Now the question is, what is the value of xz? So with this one, we can use the segment addition postulate and know that because those two segments have a common point in the middle, y, I can just add them together. 14 plus 8 equals 22. So xz equals 22. This would be another example. So points A, B, and C are on a line. I'm going to draw a line. I'm going to add points A, B, and C. So this one tells me A to B is 5, and A to C is 19. So that's not the second half of the line. A to C is the entire thing. So we're trying to figure out what is the value of BC. So because we know the entire distance is 19, one section is 5, so rather than adding this time, I actually have to subtract. So I would do 19 minus 5. And the missing piece, BC, would be 14. So this is why you always want to draw a picture. That way you don't just assume you always have to add or subtract. You need to draw a picture. That way you can visually see, like, what operation do I have to do in order to solve the problem. Then we can also apply the segment addition postulate with algebra. So we can have some variables in there. So in this example, they give me the picture, but then they also tell me that JL is 25. Because that's not on the picture yet, the first thing I'm going to do is add that to the picture. So whenever you're given extra information in geometry, always make sure it's on the picture. That's 25. So we're going to set this up the same way, except now I need like an equation so I can solve for n. So I know that if I have a segment, the two small pieces, this piece plus this piece, is going to equal both of the pieces together. So that's how we're going to set up the equation. So the first segment, JK, is 3n, plus the other segment is 5n minus 7, and together they equal 25. So at this point, we're just going to solve for n. So when I'm solving equations, I always want to simplify first or combine any like terms. My like terms are 3n and 5n, which will give me 8n. And then I rewrite everything else. Then I undo addition and subtraction, so I add 7 to both sides. Divide by 8, and I get n equals 4. So n is 4. Then at this point, we can take the 4 and plug it back in for n to figure out what each piece is. So whenever you plug in a number, you put it in parentheses. So I would do 3 times 4. That equals 12. So from j to k is 12. Then 5 times 4 minus 7, because n is 4, get 20 minus 7 is 13, which means KL equals 13. An easy check then would be, I know the entire distance is 25, so if I add those two numbers, 12 plus 13, I get 25, and I know I got the correct answer. This will be another example. This one tells me that AC is 17. That's not on the picture, so I'm going to add that to the picture. A to C, that's 17. So when I'm writing this equation, I need to figure out like what two things are going to be equal. So if I look at the picture, I notice that this segment and this segment together are going to equal 17 because that is what it says. So that's how I'm going to write the equation. I'm going to write 2x plus 1 plus 4x minus 2 equals 17. So I didn't use the 8x minus 5 because that wasn't a part of the 17. Oh, sorry. So I'm going to combine my like terms. Undo addition and subtraction. And then divide. So I get x equals 3. Then I can take that 3 and plug it back in for x to figure out what each piece would be. So this one's asking for CD, so I would do 8 times 3 minus 5. 24 minus 5 is 19. So CD would equal 19. And we're going to stop there. With this type of problem, you would just draw your picture first, and then you would do the same thing.